Okay, hi everybody. Today we'll continue our subject for the addition on the carbonyl for the ketone and aldehyde. And we talked about before that with about the mechanism. We said for strong nucleophile the addition will be happen and then protonation, or by using catalyst. If you use the neutral nucleophile, the protonation will be happened and then the addition of the nucleophile. Then what about the nucleophile? He said, look here, chlorobromiode, the halogens are good nucleophiles in substitution reaction at what? sp3 hydrazide carbon. Okay, why sp3? Okay, because it can be polarizable. Okay, but they are effective nucleophile in addition. Then, for replacement, if you have substitution on the carbon sp3 hydrazide, that meaning it will be good nucleophile. To remove a replacement, that meaning remove a group and then added another group. This is the substitution. But here we talk about the addition, not the substitution. For the addition, the process, it will be different. Okay. Why it will be different? Because he said here, look, in addition of the halogen minus to the carbonyl group, will cleave the carbon pi bond oxygen, okay, forming alkoxide. This alkoxide, okay, oxygen minus. And because the halogen is good leaving group, weaker base, look, weaker base, good leaving group, that meaning again this negative charge, it will be make pi bond, and the chlor, it will be leave again. That meaning the reaction, it will be not go to the product, it will be reverse, come back again to the starting material. Okay, that meaning the halogen, it will be attack and then it will be removed. It will be attack, it will be removed. That meaning for the addition reaction, the halogen are not suitable. Okay, not good. Why? Because the halogens weaker bases, good leaving group. Okay, this just about the nucleophile. For the addition, we can use another nucleophile like alkyl anion, like NaOCH3 for like methoxy, ethoxy, or maybe alkyl anion from the Grignard reagent. Like this, we will take it. Nucleophilic addition of the H minus, the hydride, and R minus, alkyl anion. Okay. A treatment, he said here, treatment of aldehyde or ketone with either NaBH4, sodium biohalide, lithium aluminum hydride, followed by protonation. Okay, that meaning the addition will be happen, and then protonation from the H2O for primary and secondary alcohol. Okay. طبعا what is the benefit or the useful of the NaBH4 lithium aluminum hydride? طبعا source for the hydride, we take it before that. For the reduction, it is like reduction. Okay, reduction. That meaning this reagents, both of them is for source for the hydride H minus. H minus, we know H minus strong base. Okay, strong base, we take it also before that. Strong base is directly attack the carbon for the carbonyl group to make intermediate with alkoxide with oxygen minus. Oxygen minus, after that it will be protonation from the H2O to give you this product. Okay, that meaning two step. The hydride attack and then a protonation. Two step. And the reaction result is an addition of the element H2 across. Look, overall result of reaction is the addition of H2 hydrogen gas across what? On the carbon oxygen across carbonyl group. That meaning the hydrogen will be here, also the hydrogen it will be here. Just added hydrogen here and added hydrogen here. This overall reaction. I think it's clear. If you have a question, you can ask. He said here, hydride reactions of aldehyde and ketones occurs via two-step. That meaning the mechanism, it will be via two-step. Okay. Nucleophilic attraction, and then followed by protonation. Yes, the nucleophile, we have the nucleophile here, the H minus, it will be attack this carbon, and the pi bond, it will be open. It will be alkoxide, this intermediate, this alkoxide not stable, it will be take a proton from the H2O, protonation, to give you alcohol. Okay, and lithium OH, this is side product as a salt. And here treatment of an aldehyde or ketone with either an organolithium, okay, or a Grignard reagent. طبعا Grignard reagent R MgX, you know Mg is plus 2, X minus R minus, overall charge it will be 0. Also for the organolithium, okay, organolithium. Lithium is positive and R it will be here negative. Overall charge it will be 0, and this and this organolithium and Grignard reagent طلبة is source يعني مصدر for what? For R minus alkyl anion. Okay, alkyl anionic. Alkyl, if you say alkyl anionic group, that meaning nucleophile. Okay, nucleophile. Anion minus R minus. Followed by water from primary, secondary, tertiary alcohol containing a new carbon-carbon bond. Okay, containing what? A new carbon-carbon bond. طبعا for organic reaction, any reaction give you a new carbon-carbon bond is important reaction because used to make build big structures. Okay, from the small starting materials. For this reason, this reactions are important in organic chemistry. Okay, organolithium and Grignard reagent source, we said before that for carb anion alkyl minus. Okay, and it will be nucleophile. And the addition, it will be happened on the across carbonyl group, across this. That meaning this R minus or this R minus, it will be nucleophile attack this carbon, and this it will be opened, it will be oxygen minus. Oxygen minus after that protonation give you the product. Okay, give you primary, secondary, or tertiary alcohol depending on your starting material and the type of Grignard reagent. Look here, the nucleophilic addition of the carb anion to aldehyde and ketone across via two-step mechanism. Okay, the same. Okay, the same mechanism. Nucleophile addition and then a protonation. This benzene lithium. Okay, benzene lithium. This it will be phenyl anion. Phenyl anion, it will be attack this carbonyl, and this it will be open, and then a protonation. Okay, to remove the negative charge from the oxygen to give you the product. And the product here is secondary alcohol. Also with one part aromatic and the second part it will be aliphatic. And he said, look to this compound. This compound is carbonyl group. He said, draw the product. طبعا including the stereochemistry أو إنها مطلوبة. Including the stereochemistry, we don't take the stereochemistry. Maybe next year, inshallah. Formed in the following reaction. Okay. Now you have carbonyl compound and you have Grignard reagent. Okay. 100 by 100. The CH3 it will become to here. And this it will be OH. Look to the final product, CH3OH. How? The CH3 minus attack the carbon. This pi bond it will be open on the oxygen and to give you alkoxide protonation to convert the OH minus to the hydroxyl group. Easy and mechanism also not difficult. This homework, draw the product for each reaction. طبعا stereoisomers, I don't want stereoisomers, just I want to write the product. Okay, write the product here. Write the product here. Okay. Now NaBH4. Okay, and this source for the hydride and this solvent. It is like H2O, the methanol. We can, after that, oxygen take a proton from the methanol. يعني methanol can be used for protonation also because has hydrogen. Give you the product. Also, this write the product here. And then this reaction, طبعا this type of reaction for Grignard reagent and lithium organolithium compound used to prepare a primary, secondary, tertiary alcohol. Depending on what? Depending on the number of alkyl group bonded to the carbonyl group. Now, if you take the formalin, this is the formalin, formaldehyde. The R minus, look here, hydrogen, hydrogen. Okay, now this it will be OH and the R it will be here. That meaning it will be primary alcohol, primary alcohol. If you take one R group, it will be secondary alcohol because one R group on the molecule and one R group from the green reagent, it will be two group on this carbon bonded to the OH. That meaning it will be secondary alcohol. If you take ketone, the ketone and additional R group, overall reaction, it will be tertiary alcohol. Okay, that meaning we can prepare primary, secondary, tertiary alcohol from different starting materials with Grignard reagent or organo lithium compound. And here the nucleophilic addition of Sm minus cyanide, okay, cyanide compound. Okay. Now this Sm minus cyano group, this cyano group also, if you look, we have negative charge, okay, because carbon negative, triple bond, 3 bonds, 1, 2, 3, nitrogen, okay. That meaning this can be act as nucleophile again, and the same mechanism, okay, the same mechanism. Just look here, NaSN, Na positive, Sm minus, Sn it will be attacked from here, and this it will be open, and then a protonation to give you the cyanohydrin compound, because we have cyano group and we have hydroxy group. This compound called cyanohydrin compound, okay, cyanohydrin, that meaning with OH and with CN groups. This reaction add one carbon. Look, this reaction adds one carbon to the aldehyde or ketone. That meaning we have a new carbon bonds. Okay. Also, this reactions is important for inorganic chemistry for synthesis. The mechanism, okay, the same mechanism, nucleophilic attack and then protonation. Okay, look, nucleophilic attack, open, minus, minus, protonation, okay, to give you the product. To give you the product. That meaning easy mechanism, nucleophilic attack, step number 1, step number 2, of protonation. He said here addition of primary amine. Okay, we know primary amines or the amines compound has unshapeable ketone. Look, we have unshapeable ketone here. We have unshapeable ketone here. We have unshapeable ketone here. Okay, then it will be act as nucleophile. Yes. Okay, then when the amines can be act as nucleophile, then we have to think the amine compound can be added on the carbonyl group for the ketone and aldehyde. Okay, maybe can be added. Okay. Now, where is the difference if you use primary amine, if you use secondary amine, if you use tertiary amine to react with carbonyl group with aldehyde and ketone compounds? Okay. Okay, here's the idea. Now, he started with the primary amine. طبعا we know move one of the reaction aldehyde and ketone with nitrogen or oxygen heteroatoms. Amine, from example, are organic nitrogen compounds that contain mono-bonded electron pair. We have unshape electron on the nitrogen. Okay, amine as classified, we know that primary, secondary, tertiary, depending on what? This is primary amine. Why? Because just we have one alkali group bonded to the nitrogen. This secondary because we have two alkali group bonded with the nitrogen atom, and this is tertiary amine with three groups, alkali groups bonded to the nitrogen atom. Okay. He said both primary secondary amine react with aldehyde and ketone. Both of them. And the tertiary cannot be react. Okay, why? We will be know why. Then, the primary secondary amine can be react with aldehyde and ketone. Okay. We will take with the primary amine. Okay. For a primary amine, he said formation imines. Imines. What meaning imines? We will know. Look, treatment of aldehyde or ketone with the primary amine afford an imine. That meaning if you have a primary amine and aldehyde or ketone, the result it will be what? Imine. Okay? Imine. That meaning this compound, carbon double bond nitrogen, this functional group called imine. Okay? Imine. In another word, they called Schiff base. Okay, Schiff base. This is the Schiff base, the amine compound. Okay. Nucleophilic attack of primary alcohol in the carbonyl group form unstable carbonyl amine. That meaning, if you have amine compound, this it will be attacked with the carbonyl here, give you carbonyl amine. This carbonyl amine, not a stable compound. Okay. How it will be to convert to the stable compound? By removing, by elimination of H2O molecule. Look, we have hydroxyl group on the carbon, and at the same time we have NH group and this and the same carbon. This give you unstable compound. Okay, unstable compound. This it will be not a stable intermediate. For this reason, this compound attempt to remove H2O molecules from the structure to give you the amine. Okay, where is the H2O? If you want to remove H2O from here, this OH and this is the H. Okay, this OH and this is the H. Remove this OH with this H and make pi bond here. Okay, it will be double bond. It will be give you amine compound. Okay, amine compound. Amine compound is stable compound, and طبعا overall reaction طلبة. Overall reaction is remove this H2 with this oxygen and put the nitrogen here. This overall reaction. Okay, that meaning is easy. Because the nitrogen atom of an amine is surrounded by three groups. Okay. Where's the three groups for any nitrogen? Maybe alkyl hydrogen, maybe three hydrogen, maybe two alkyl, one hydrogen. Okay. Two atoms and one lone pair. Yeah. It's sp2 hybrazide. Okay, that meaning this here, the nitrogen here, now is sp2 hybrazide. Okay, we have one group, two, and the unshape of electron, 1, 2, 3. Okay, 1, 2, 3. Also this one, this two, and the unshape of electron sp is it will be planar, trigonal planar. Okay. Trigonal planar, making carbon nitrogen R, this carbon nitrogen R, this carbon nitrogen R. Okay, the angle it will be here 120. Amine formation is fastest when the reaction medium is weakly acidic. Okay, that meaning the reaction will be very fast if you use weak acid as catalyst. Okay, not strong acid. Why not strong acid? if you want to know why we cannot use strong acid, because the strong acid directly it will be react with the amine. Amine is bases, okay, and strong acid to be react with the amine to give you a source, and there is no reaction. For this reason, we will use mild acid, weak acid. Okay. Now, take this. We have carbonyl and we have imine. Just remove the oxygen, put the nitrogen, and remove the 2 hydrogen with the oxygen. It will be minus H2O. This oxygen with 2 hydrogen it will be H2O, and directly it will be have imine. This 2 hydrogen with the oxygen, remove it, and then put the double bond between the nitrogen and the carbon to give you the amine compound. This is the amine, this is the amine. The mechanism, this is the mechanism. Look, the amine, it will be nucleophile, attack the carbon, give you this intermediate, a protonation, okay? Protonation transfer, that meaning we have transfer protonation from the hydrogen. We have 2 hydrogen here. One of them, it will be removed, transfer from here to here, okay? That meaning the oxygen minus take 1 proton from the nitrogen to give you carbonyl amine. Now, carbonyl amine, not a stable compound, it will be happened elimination for the H2O. How the elimination will be happened here? Look, the unshapophilic electron for the hydroxyl group take 1 proton from the medium, چونكو وسط حامضي, okay, from the medium, and to give you OH2 plus, very good leaving group. The unshapophilic electron for the amine it will be make double bond, and this it will be leave, okay, to give you this intermediate, okay, this intermediate a positive charge on the nitrogen. Now again, this positive charge on the nitrogen has resonance. This pi bond can be equal the positive on the nitrogen, and the positive it will be converted to the carbon. That meaning is slightly stable because we have resonance stable. Okay. Now the final step, the unshapophilic electron for the medium H2O and the medium, it will be take a proton, and this it will be equal the positive charge. The both of the electron for the bond between the hydrogen and nitrogen, it will be go on the nitrogen to remove the positive charge from the nitrogen to give you the final result. This your final result is imine. Okay, this is the imine compound. This is the mechanism. Okay, this is the mechanism. We have addition, and we have it is like rearrangement to give you the imines.
سيدا بس الشيء خطوة ما هيك بيجي first step part 2.
Okay, part 2 تمام. Part 2, look, we have this compound not stable. Why not stable? Because we have 2 functional group, OH minus, this كحول, and we have NH with unshapophilic electron. Okay, this is amine. Both of them different functional group at the same carbon, okay? And both of them this high electronegativity. Also the nitrogen is high electronegativity. Okay, both of them is the carbon, this give you not a stable compound. Okay, how it will be converted to the stable compound, to the amine, by this step. Okay, now how the unshapophilic electron for the OH take a proton from the medium وسط. معناها قلتي وسط mild acid. Okay, that meaning we have acid in the solution of reaction in the medium. Okay, that meaning it will be take a proton from the medium. Okay, that meaning a protonation for the hydroxyl group to give you what? To give you OH2 plus. Now OH2 plus, good leaving group or no? Yes, good leaving group. Okay, now we have unshapophilic electron here. This make double bond, and this it will be leave. Leave as what? Leave as H2O. H2O stable or no stable? خلاص. Okay, now give you this compound. This compound with positive charge. This positive charge is stable or no? If this positive charge not stable, that meaning cannot be converted to the amine. If this positive is stable, that meaning can be converted to the amine. Okay, Now, my question is stable or no? The answer, it will be stable. How it will be stable? Because we have resonance structure. Okay, this resonance structure. Okay, now we have double bond here, and this pi bond, it will be open, and positive charge, it will be on the carbon. That meaning we have two resonance structure. Resonance structure stabilize the positive charge. Okay, now at the final, how we can remove this positive charge to give you the amine? Okay, it is easy. Just remove the proton. Okay, remove the proton by the H2O, because our H2O is nucleophile. Nucleophile can be remove the proton, and this both of the electron between the hydrogen and nitrogen, it will be added on the nitrogen to equal the positive charge. Okay, finally it will be give you the amine. Okay, how hard do electron vary? It will be go to the nitrogen atom to give you the amine compound. This the amine compound. تمام، واضح هنوكا؟
سيدة يعني حتى كو positive charge ببين فيتن H2O يبين دا كارليك قال H كاتن.
ما أنا positive charge تنسي separate compound with positive charge. يعني positive charge give you not a stable compound. Yes.
Yes.
Yes. How we can remove this positive charge? It is easy. Just remove a proton, okay, from the nitrogen that have positive charge, and both the electron, it will be go to the nitrogen to remove the positive charge. Okay, يعني it is exactly like H3O plus. You know the H3O plus. This. You know this?
Receito psirako di buchit mechanism do H3O و اگه که بر هم H2O.
Okay. This H3O plus, this H2O, yes?
سيد product ده وقت ایمین درد کبیدن. قالوا H3O.
مانا I'm very good صحكي. I'm very with mild acid. With mild acid. يعني تا H2O هيا وبلس بروتون اسيد بنتشيها H3O بلس معنا؟
باي.
فهذا شنكو عم استخدام ميلد اسيد يعني ويكلي اسيد ويكلي اسيد. فام يعني already automatically we have acid on the inside the solution in the mixture. Already we have acid. Okay. تمام؟ درست. Okay. Do you know this buffering? I think buffering you or maybe another student. This H3O plus, do you know this? How we can remove the positive charge from this?
Say that the HB?
خلاص. Remove hydrogen and the positive charge, it will be equal. The same thing here. Remove hydrogen and the positive, it will be equal.
درست سيد.
وخلاص. Okay. This homework for you. Draw the products formed when this compound react with each carbonyl compound. Okay, that meaning you have here primary amine react with this, react with this, react with this. Okay. طبعا look in the presence of what? Mild acid. That meaning we have mild acid as catalyst. Okay. That meaning we have mild acid as catalyst. Just I want from you to write the product. Okay. If you want, you can write the mechanism also. This for you. If you want, write the mechanism for reaction between this or this and this. Maybe one of my question in your exam, it will be write the mechanism between reaction of this compound with this. I want the mechanism. Or this compound with this. I want the mechanism. Okay? You have to know the mechanism. The same for this. But the R group, it will be different. Okay? The R group, it will be different. What? Okay, he said, what the primary amine and carbonyl compound are needed to prepare each imine. That meaning this imine. Okay. He said what a primary amine, كش primary amine وcarbonyl compound can be give you this imine. Easy. Make this two part. This part for carbonyl and this part from the amine. Okay, and also here make two part this. Okay, this cut from here. This from carbonyl and this from amine. This easy question. Okay, this so easy question. Do you understand this or no?
No, لا سيدة نجحت.
والله صح كده. This product أو ناتج أو متفاعل. He want the reactant. This is the product. He want the reactant. Okay. If I say to you, I want from you to prepare this compound. How you can to prepare this compound? This compound. How? How, Bafrin?
السيدة وكياوني كان ميكانيزم معار كرتين.
يعني أو شيء imine can be prepared from two compounds, or from ketone with amine. معناه؟
بله.
اوكي. يعني تلازم هزا خبكة أو إيمينا هزا خبكة تلازم كيتونة بنفيسا وأمين بنفيسا. إنه كش كيتونة هاو استخدام كريا أو استخدام CH3 كربونيل H. أوكي. أسيتال. أوكي. CH3 كربون دبل بوند أكسجين H. وكش أني أمين he used here. He used primary amine or secondary amine. He used the primary amine. H2N CH2 CH3. Okay. تمام.
درست سيدة.
واضحة أن؟
بله.
Okay, واضح. هذا same thing here. Okay. This amine, this part, look, this part come from ketone, just double bond oxygen. Or this part come from amine, just here put here hydrogen. Aniline, this aniline compound. طلب benzene with NH2 chia. Aniline. Okay. This aniline and this come from the cyclohexanone. Okay. This is the addition of primary amine. Primary amine give you amine. If you use secondary amine, not give you amine, give you an amine. Okay? Enamine. We said enamine in organic chemistry. Enamine. That meaning we have a double bond, alkene, in, and we have amine, enamine. Okay? Enamine. That meaning if you use the primary amine, give you amine. If you use secondary amine, give you enamines. Okay. How the enamines? طبعا the same thing. This secondary amine nucleophile attack the carbonyl, and this it will be open to give you OH. This OH NR2. Okay, this also carbonyl amine. This carbonyl amine not stable. Okay, remove H2O. Where's the H2O? This OH. Where's the hydrogen, Talaba? This is the hydrogen, yes? Okay, yes. That meaning remove this, and the double bond it will be here. Okay, the double bond it will be here, not here, not between the carbon and nitrogen, because the hydrogen here on the carbon, this carbon and this carbon. That meaning the double bond it will be here, between this carbon and this carbon, to give you enamines. Okay. That in case if you use secondary amine. Okay, look, cyclohexanone. Okay, this secondary amine, the nitrogen it will be here, but the double bond it will be here, the double bond. Okay. How? Added this here, and this it will be open, this it will be OH, and then we have to remove H2O, because this OH with this hydrogen, that meaning the double bond will be here. Also we use mild acid. Okay. Like he said here, like amines, Enamines are also formed by addition of the nitrogen nucleophile to the carbonyl group, addition of this to the carbonyl group, followed by elimination. That meaning the next step, it will be elimination of the water. Okay. And then elimination occur close to adjacent carbon. That meaning the elimination will be happen between two neighboring carbon, between this carbon and this carbon. Okay, between this carbon and this carbon. Okay. أو مهمة طلبة adjacent carbon, that meaning neighboring carbon. Okay. أو مهمة هذا neighboring carbon. Where is the neighboring carbon? This carbon for carbonyl and the second carbon. Okay, between neighboring carbons atoms to form a new carbon-carbon pi bond. Okay, now look, this acetone and this secondary amine, what will be happened? This, it will be here, and we have the double bond here. Okay, the double bond here. This enamines. Okay, the mechanism for the enamines formation. بله
بوچی aldehyde map کرنه اینا
aldehyde
انا سيدا مع aldehyde چی بکردینا و کیتون چی ویره بس کیتون بوچی
تشيل aldehyde استخدامك
يعني
لا أنا aldehyde بس هكا aldehyde تستخدامك دبنا چی ها
ای جای دبره و بیت باشی باشی دبید بس رخه که دبل بوند بید مانه سيدا
رخك بس ويا دي هيدروجين
درسته
okay. I want to remove this, just 1 minute. Okay. The mechanism for the enamines formation, this is identical to the mechanism for the imines formation, except for the last step. Last step different. He said the same mechanism, just the last step is different. Okay, last step is different. Okay, and he said in formation of the pi bond, the mechanism can be divided into distinct part. Nucleophilic addition of the secondary amine followed by elimination of the H2O. Yes, we know this. Where is the mechanism? This is the mechanism. Secondary amine, it will be added, and this it will be open. Oxygen minus protonation give you OH. OH, and here NR2. This carbonyl amine. Carbonyl amines not stable. Okay. Now we will be convert this compound to this. How? By this. Look. OH group take proton from the medium to give you OH. H2O plus good leaving group. This unsubstituted amine on the amine, it will be make double bond, and this it will be leave to give you this compound. This compound is slightly stable. Why slightly stable? Because we have resonance structure. Okay, resonance structure. Now we have here on the alpha carbon we have hydrogen. H2O, it will be remove the proton. And this pi bond, this both of the electron between hydrogen and carbon make a new pi bond, and the pi bond between carbon and nitrogen will be open to remove the positive charge to equal the positive charge to give you finally enamines. Okay, enamines. This is the steps to convert the carbonyl amine to the enamines. 1, 2, 3. 3 steps. Okay. 1, 2, 3. Step number 1, protonation. Step number 2, elimination of the H2O molecule. Step number 3, remove the positive charge from the nitrogen. Okay. Look here. This cyclohexanone primary amine give you enamine, give you imine. Okay, cyclohexanone with secondary amine give you enamines. Look the different. Look here the different. This imine double bond between carbon and nitrogen. The enamine no, the double bond between two neighboring carbon. This carbon and this carbon. Okay, the carbon for the carbonyl group and the adjacent carbon, the neighboring carbon. Okay, look, this is the difference. This imine, this enamine. Both that meaning the primary amine and secondary amine give you different product when they react with the carbonyl groups. Okay. Again, this أو ملاحظة طلبة أو مهمة. With the primary amine, the intermediate imine anions still has a proton on the nitrogen that may be removed to form what? Carbon double bond nitrogen. This carbon double bond nitrogen. This. But with secondary amine, no, it will be give you carbon double bond carbon. Okay, carbon double bond carbon. This is the difference. Now the hydration. If you have aldehyde or ketone and make hydration, طبعا hydration by using acid or base. Okay, hydration meaning added H2O molecule across the carbonyl group. Okay, you have here H2O. That meaning we will add the H2O here across on the carbon double bond oxygen. Okay, this proton it will become to here on the oxygen, and the OH it will become to here. Okay, give you diol hydrate compound. Okay, this we have dihydroxyl group, both of them bonded at the same carbon. Okay, we say this diol يعني dikahol. Okay, dikahol. Gym meaning hydroxyl bonded at the same carbon. We say diol. Okay, we say diol. The treatment of carbonyl compound with H2O and the presence of acid or base catalyst added to the elements of the hydrogen and the hydroxyl across to the carbon oxygen to remove the pi bond, and then give you the diol, and it is the hydrate compound. Okay, that meaning compound with the hydrate molecule, with the H2O molecule. Okay, this formaldehyde H2O, it will give you formaldehyde hydrate. This ketone with the H2O, it will give you OH here, the hydrate compound, give you the hydrate compound. Okay, the mechanism also the same thing. طبعا the OH, if you use طبعا here base catalyst addition. Okay, base catalyst addition for the H2O molecule to the carbonyl group. We said before that we can use acidic medium, we can use base medium. That meaning the H2O itself added slowly to the carbonyl group. Both acid-base catalyst can be used for this addition. Okay, and base the nucleophilic OH minus, and the mechanism followed by usual two-step for the nucleophilic addition, the nucleophile attack and then a protonation. Yes, this nucleophile attack give you O minus, a protonation give you the product. Okay, but for the acid, no. For the acid, it will be protonation and then nucleophile attack. Okay, for the acid, it will be protonation, عكسها بالضبط. It will be protonation precedes the nucleophile attack. Okay, proceed. Okay, how? Acid, we know acid give you OH minus open resonance structure to give you carbocation. Here the carbocation. Now the H2O is easy to attack the carbocation because now the carbocation is full positive charge. Okay, to give you H2 plus. OH2 plus. How we can remove the positive from the oxygen? Remove one proton. Okay, remove one proton by H2O molecule to give you OH group, the diol compound, the hydrate compound. Okay, يعني do mechanism by using acid, by using base as catalyst. By using base, it will be addition and then a protonation. By using acid, no, it will be protonation and then addition. And I hope you understand this easy mechanism. Just try again to write this mechanism 2-3 times, no problem. until you understand all these mechanisms. And if you have a question, I am ready. If you don't have a question, for today it is enough. And next day, inshallah, we'll start it with a new chapter. And if you have a question, you can ask. If you don't have a question, you can leave. Take your time. Have a good day.